Hey Pierce, how's it going? This is going to be episode 2 of your daily math challenge. It's Mr. Rossiter here. You're not in my kitchen, however, you're in the plant room. Everyone got a drink today, so everyone's pretty happy. I want to show you some of the air plants that I have, and they're all very kind of almost alien. So, anywho, we got a full schedule today. We're going to be talking about your solutions. I'm going to shout out a bunch of students. We'll talk about the answer to the amicable numbers. We'll recap that, and I'll go ahead and give you your next challenge as well. Okay, so let's dive right into it. I'm going to go ahead and present some of your solutions, so bear with me here. So I'm going to go ahead and bring up Willa Kennedy. This is her work, and Willa, let's see here. Willa tried 24 and 36 and found out that it didn't work, and then tried 250 and it looks like 238. And then finally settled on an answer of 220 and 284. Here are the factors of both of those numbers. And Willa, thanks for giving it a whirl. We really appreciate your hard work on this. So we encourage all students to try your best and to share your thinking, and hopefully you'll get a good shout out. So a couple things. Again, the final answer was 220 and 284. That would be the smallest pair of numbers. And a little fun fact, guys, the next pair would be into the thousands, so it would be a lot of work to do that. So thanks for supporting our YouTube channel. We have over 125 views as of right now, so very exciting times. I also wanted to shout out Willem in 5th grade. Thanks for your hard work. You said it would be 2 and 3. The factors don't quite add up. They get 1. However, you can't include the number itself. Otherwise, all prime numbers would work. Another shout out for Ellis and Levi in 6th grade, getting it totally correct and turning it in. Thomas in 6th grade as well. Keep working hard, buddy. Joe and Camilla in 7th. Thanks for your contribution as well. Okay, so on to the next challenge. So I'm going to go ahead and bring it up. You can find this in your Google Classroom. So let's see here. Let's go ahead and start bringing it up. And your next challenge will be in, let's bring it up. Will be on triangular numbers. Okay, so triangular numbers are, what are they? Okay, so numbers have shapes to them, and we've known this from square numbers, like a perfect square, like 4, 9, 16, 25. So if you have an area of a square, a 2 by 2 square, that would give you an area of 4. And triangular numbers are kind of the same thing. They have a shape to them. So if you notice on the 2 diagrams on the left, they will, 1 dot would be a triangular number, 3 dots, they form a triangle, 6, 10, and so on and so forth. So our task right now is to imagine 2 copies of a triangular array of squares, and I'll show you a video in just a moment. And can you picture maybe how they'll fit together? Maybe take a minute to kind of think to yourselves, okay, well, if I have a staircase, and if I maybe flip those around, we're going to talk about the specialness of their dimensions in just a moment. Okay, so here is going to be your picture. And if I play the simulation, we can take a look at a doubling of a triangular number. And this is how they would fit together. So essentially, if your thinking was right, this becomes a 2 by 3. And let's go ahead and maybe play another one. So let's play the 3rd triangular number. The 3rd triangular number is 6. And if I kind of take 1 and put it on the next one, I get a 3 by 4 rectangle. Okay. So which leads me to your challenge problems for Monday. Yes, you'll have the weekend to work on this, and good luck. Here's the document. I'll go ahead and post that into your classroom as well. And here are the square array, or the array of squares that form a triangular number. And what do you notice about doubling the doubling of a triangular number. You can go ahead and type directly into this doc as well. Everyone will have a copy of it. Number 2, experiment with different triangular numbers and explain what is special about the rectangles made from 2 identical triangular numbers. You can go ahead and mess around with some of the triangular numbers. You can draw them on paper. Any work that you do, make sure that it gets into this doc. We'd love to see it. Number 3, can you write down the dimensions of a rectangle made from 2 copies of the 250th triangular number? Can you work this out to what this would look like? Okay, so here's your little check here at the bottom too. And what's fun, I just bought an Xbox, and Mr. Gerard plays an Xbox as well, and we're planning to play over the weekend. What game should we buy? And we'll go ahead and share some of your thoughts on the next video, okay? And of course, there's an extension here. If you're feeling a little under challenged, you can go ahead and give this a whirl too. So consider the following numbers. Here they are. Which ones are triangular, and how did you figure that out? And will a triangular number ever end in 3 zeros? So I'm eager to kind of get your thoughts on this, and hopefully you'll be able to give the next shout out on the next video, okay? And maybe you'll see another room in my house outside of where the plants live. So, all right, guys, be safe out there. We're thinking about you again. Reach out if you need anything, and we'll see you at the next video. Bye-bye.